Once again, this is the vector databases presentation of my cloud meetup. This cloud meetup's I started this during the pandemic. My wife said, you got to do something different. And I did. I had run a meetup before, but never had one that gained so much popularity. So I'm happy that you guys are here. It's a lot of fun for me. I'm an older guy, so I just want to, enjoy people and have fun. And I was a nuclear physicist turned programmer, and I do hold several different degrees. I love music, and I'm a fitness nut. I work out all the time. And I'm just that's kind of a very pretty much happy guy. I have about 29 certifications and growing, so I'm constantly taking new certifications. That's kind of when I started this group, I thought, well, I can teach people how to do certifications, and it's gone from there. Just a little bit of my background. I was a developer in my company present now. I became a DevOps tech lead, Scrum Master, QA architect, manager of training documentation. Before that, I worked in the government, EPA, education. I was a CSIS scholar, and I was a military captain. So if you're in your previous military, you get that. Today's presentation is two of a part three series. Part one was LangChain and Hugging Face. That video is up, and also the slides are available. So I will make those make sure when I do part three that you guys have all that. Part two is today, and it's ChromaDB and Pinecone vector databases. There'll be an icebreaker and intro. We'll talk about prompt engineering. I'm going to show you a very powerful example that I did this week. I'm going to talk about design patterns. So I really was someone that should be an architect because I like how things fit together, but I'm a horrible coder. I hate the details; they just totally bore me. But now with Chat GDP and generative AI, I don't have to worry about that because it takes care of all the details for me, and I'll show you how to do that. All right. With that said, and part three will be creating a Scrum agent. So we'll be creating an entire Scrum team that operates independently. So when you actually give it a command, it has all these agents that go back and forth and they build a product for you. So I think that's very interesting. And it's also will be my presentation to the PMI. I'm a PMI ACP to PMI.org Southwest Ohio on November 18th. So there you have it. Okay. Where are the videos? So if you go to the site, Carell, and you look at the introduction to the meetup, you'll see there's different links in the videos. There's a video channel there you can click on. With that said, we're going to move forward and a little bit about presentations. Today, of course, is ChromaDB and Pinecone. I am going to be moving some things around, so let me warn you because I want to do this agents presentation. Additionally, I am a certified Microsoft trainer. I need to recertify, and that means I need to teach a course. So I may be teaching a 4 to 8 hour course that may become part of this curriculum. So we'll see. With that said, Mastering HashiCorp has been planned for the 18th. Both PL300 and DP500 are dates that cannot be moved. So that will be the 16th of December and the 20th of January. And then prepping for the Certified Associate Developer Quantum Computing exam will be coming around 24 February. Quantum computing is coming. In about 5 years, all encryption will be broken using Shor's algorithm. So things are going to change even more rapidly. If you think things are changing now, wait till quantum computing hits the scene. All right. With that said, I'll do my standard introduction real quick. And once again, I am watching the chat. So if you have a question, feel free to say something or to put it in the chat. That said, this was my introduction, like when I first started, like what, almost 2 years ago. Coding today is like hand stitching of yesterday. The AI sewing machine is coming, I used to say, and everyone thought that's a joke, but it's here. And so and we're going through that transition, almost like a industrial revolution, where you have a whole room of workers like hand stitching, and then sewing machines come, and next thing they're all laid off, and in the back of the room you have 10 sewing machines doing the work of all these people. And I know a lot of people get nervous that AI is going to take your job, but I have some encouraging news for you, and we'll get to that in a moment. Okay. With that said, really, it's human intelligence in a box. And what we've done, we've solved the Tower of Babel problem. We've created a universal translator that codes and transforms, and that really means something special to me because when I say transforms, I think parallel. So you think we're having a conversation today, and we're talking back and forth and back and forth. That's a linear process. But imagine if I could come to your desk and I could dump all my words on you at once. You parallel process them and you tell me what I'm going to say to you tomorrow. That's pretty much what we have going on here. With that, we've talked about copyright. I'll move on with that. It's transformational, so it's going to be difficult to get that on these systems. And I've talked a little bit about the AI timeline, so I'll move on with that. The one thing I do want to say is because of dimensionality, There is so much to do and not enough people to do it. So that's the good news. And what I'm saying is if we remain status quo, yeah, I say then yes, AI will take our jobs because if we just stay where we're at. But that's not what happens with technology. What happens with technology, you create new experiences, new products. Houses an infinite amount of work. So essentially, there's more work to do, not less, but that takes specialization and takes retraining. But luckily, this stuff is really easy to program, so I'm going to show you how to do that today. So with that, any questions before we move on? Now, I might have used this one last time, but we'll use it again. It's a good one. Have you ever wished you could enhance a part of your brain to gain superhuman abilities? What part of your brain would you expand, and what would the enhancement do, and how would it make you superhuman? So does anyone want to take a shot at that? And the reason I like this one is because it really applies to vector databases, because in a sense, a vector database has enhanced the brain of a large language model, and we'll talk about that today. So anyone want to take a stab? What would you do? And John just said in the chat he would do logical processing. Vitaly said computational and languages. Yes. Do you mean uh, foreign languages or do you mean computer languages? Been a great conversation. Thank you so much, guys. We're going to move on, but if you had an idea burning in your heart that you need to put out there, just go ahead and hit the chat or just let me know. Feel free. All right, just to review real quick, we did do in part one and go over on getting started with Hugging Face is a real exciting website. It's almost like a GitLab. It allows you to throw code up there and immediately have it running, and everyone can see it. It's a repository. And we talked about the ways to program AI, and we talked about the different interfaces like Streamlit, Gradio, Docker, and Static. And today we'll be concentrating on Streamlit, so we'll stick with that today. All right, part two, we're going to get started with vector databases. But before we do, are there any questions? And let me go ahead and paste the links one more time in the chat, because I know if you join late that you may not see the links in the chat. So let me go ahead and put those in there right now. With that said, part two, ChromaDB and Pinecone. All right, so I want to just cover prompt engineering again, so you kind of get more of a holistic view of it. And basically, you're probably hearing stuff like one shot, few shot, chain of thought, and simple chaining with memory. And you're probably, what the heck is that? Well, one shot is like you just ask a simple question to a large language model and it replies. And few shot is where you might ask it a question, but you give it examples and it replies back on those examples. And chain of thought is where you have a whole list of things for it to do and it concentrates on working through those things. You're starting to see evolve to the idea of using agents, because we're going to use chain of thoughts when we build agents. And in terms of one shot and few shot, there's a few things that I like that I do. And one is, of course, with there's four things here, and that's instructions, context, input example, and output indicator. I love the input example and output indicator. We're going to use that today to create a program. And the program we're going to create is a weather program. And so I have this out here. You can go ahead and go to the Hugging Face if you want to, and you can actually, now I didn't give you my weather token because I didn't want to hand that one out, but I did for the rest of these programs, I am going to, you are going to have the tokens. Let me see if I have the weather program up, then I'll run it for you. One moment. Let's see if I have it up here. I think I have it up here. There you go. I have it up here and I have the token in here. I actually wrote this program in 5 minutes, and we're going to write it in 5 minutes using ChatGPT. And basically, it's a weather program. And so you just go and it works on open weather. And you just go, well, what is the weather? Weather in London. Okay, and you can do that. Then it gives you back the weather. Or you can go, what is the weather? I'm in Florence, Kentucky. In Florence, KY, and you have to make sure you put United States, and it's going to give you the weather there. Give me the 5 day forecast. No, I'm not filling in anything. It's just interpreting what I want, which is really cool. And there's my 5 day forecast. Now, let's write this, in ChatGPT. And so let me show you how to do that. So what I'm going to do is I'm going to use a prompt, and I'm going to say, okay, I'm going to instruct ChatGPT to integrate LangChain and Streamlit and set up inputs for API keys and pose a weather-related question and use the details from chat open weather map link. So what happens lots of times as a developer, or even as a front-end guy, I want to write nice front-end, but I have to look at code and then I have to somehow figure out how all the code fits into the front end. Well, ChatGPT leaps all over all of that. Okay, I'm going to show you how that works today. And this like is like life-changing stuff. So you come here, you're going to go to ChatGPT. I'll copy some of this into a prompt, some of these prompts. Let me create a new chat. And what I'm going to say is, okay, let's do that. Let's pose a weather. Let's put it in here. Let's integrate LangChain come on, Streamlit, and I'll put that in there. And then what I have lots of times from the following code. Now this is interesting. I'm giving it a prompt example. So I'm saying, hey, I have LangChain and I have Streamlit. That's going to be my interface. Set up an input for the API keys. Pose a weather-related question. I want that in the interface, and use the details from the following code. So lots of times I'm finding code snippets on the web that I'd like to build interfaces out of. So let's take a look at that code snippet. We'll go there right now, and there's a bunch of code. And but it doesn't have an interface. But I'd like to be able to work with it and play around with it without having to go into Jupyter Notebook, then into PyCharm, and then into Hugging Face. So let me just, and you can think, well, I have to organize all this, and then I have to, no, I don't have to. Let's just copy it. It's just all a bunch of crap. So let's copy all the crap, okay? And it gives me the way the output should look as well, and just copy all that crap and throw it in the ChatGPT because it doesn't care. It's just going to go, okay, I'm going to figure it out and run it. And now within just a few minutes, it's going to crank a program out for you. There you go. It's going to install that Streamlit, install LangChain, and it's going to create your input for your Streamlit right there. And you have your LangChain with your utilities, your wrapper, your OpenAI. Then what it's going to do, it's going to start creating some environmental variables for you. And there's your OpenAI key, and there's your weather AI key. Yeah. And it's going to there's your large language model you're going to use to talk to the weather agent. It's just nuts. And then it's going to just work it all for you through here. Excuse me. Sorry. And then what I did after it wrote that for me, I just copied and pasted into Hugging Face. And when I did, out came this program. I went, oh my Lord. I just couldn't believe it. And it worked. And I went, oh my goodness. And that opens up so much that I can do. And as we go through these LangChain docs, you start looking at it, you're going to see all these code snippets. And you're going to want to run them and play around with them. But how do you do that? Because now you have to go through this very intensive process of building an interface. No, you don't. Just say, take this same input, say, hey, take LangChain and Streamlit, build an input to this code, and it will. I throw it up on Hugging Face or PyCharm, whatever your tool of choice is, and run it. And there may be a few bugs, but then you just throw the bugs in there, say, fix it. And so it's a different way of thinking about coding. So I hope you enjoyed that example, and the rest of them you'll be able to run with your keys. I just didn't want to put my weather key on there. There you go. So if you have any experience, yeah, thank you, Fred. Fred said, wow, what dark magic is this? You're right. And you're going to see a lot more of it, Fred. We're just getting started. So if you've done any codeless coding, I got to tell you, it's dead. And I have, and I've studied the codeless coding systems, and it's so hard to build the interfaces and get the code working. But what we have here with prompt engineering, you get code, you got an interface, hey, put them together, give me an application. So it does it very rapidly. And then you go extend that application and do this and add that and take this away. And that's the type of programming that you can do with these generative AI systems. Now, one of the things I spoke about this last time that really surprised me, and I think I was talking to someone earlier about large language models and neural nets. This is what I was pretty much trained on. And if you wanted something, you had to run it through your training model, or you could do transformation on it as well. But here came these knowledge bases that you can add to it. And these knowledge bases are vector databases. All right, with that said, vector databases, if you study them, kind of had their roots in Word2Vec. Did anyone here have any experience with Word2Vec or work with Word2Vec? Yes, as Fred said, he's familiar with Word2Vec. Okay, so yeah, and so Shreya said, yeah, I'm definitely familiar with Word2Vec. Well, this is kind of the heart of what's going on here with these vector databases. I got to explain. It's very important that you understand this concept. If something similar in a multidimensional vector space, it turns out they're close together in that space. That's called nearest neighbor. And so they learn how to take these words, faces, different knowledge bases, and turn them into vectors and throw them into this multidimensional space. So for example, you can see a king might be close to a man or to a queen, and a queen might be close to a woman. So these might group close together in vector space. Now, why this is so important, it has to do with the way you process data. If I have a large document, and I chop that document up to smaller pieces and I want to search that document, I'm searching over all of that document. It's very intensive. But if I throw that document, all that document, no matter how large, into a multidimensional vector space, then everything that is associated with something I'm looking for is close together. So if I take my question and I embed it and throw it in a vector space, that question will be close to that data. So I don't have to go over all those many documents that have been chopped up and put into that database. I can just look for that in multidimensional space and it's super fast. And that's the key that makes this stuff so usable and so incredible because it allows you to deal with large quantities of data very rapidly. And this is all called K nearest neighbor. And I mentioned I had created something called Hunter's algorithm for my thesis proposal many years ago, which uses quantum computers, which are here now, coming now. So I won't be able to do my thesis for the next 5 years. So I don't care. I like it. But you're seeing once again, and the thing I'm trying to iterate with K nearest neighbor, if concepts are similar, they are close in multidimensional space. And so we have and so that's good. That's a mechanical system. But now we have LLMs. And so these large language models can talk to these multidimensional spaces as if they're human and take that feedback and talk back to us as if it's human. And that's the kick that we're getting here. All right. Any comments before we move on to the next slide? So what we're going to be doing with these vector databases is you're going to be taking content. Yeah. Okay. So Vitaly says how it deals with words that can have the same string but several different meanings. What it does, it does parallel processing over large quantities of data. So it's looking where not just how those words fit one after another, Vitaly, but how those words fit in an entire context. And then it's training, it's training billions of words, billions of interactions on the neural net. Yeah. So what we're going to do today, when we build one of these applications, we're going to take a data set and we're going to embed that, create an embedding, and we're going to put that embedding in a multidimensional vector database. And we'll do that a few times today. And I'm going to talk through this example a few more times. All right, before we do that, I actually want to show you a multidimensional vector. And this one is one you typically find in LangChain. It has 1,536 dimensions, okay? So this is your vector creator program, and you do have a token. So let's go ahead and bring this one up, and we can work this one together. What do you think? So once again, if you don't have the tokens, I'll paste them in. Oh, is vector context aware? I'm thinking about that question, Vabhav. And the reason I'm thinking about it is because it's the way it is created. Okay. So it's created from context. All right. So that's an interesting question. Kind of reverses the question. It's created from context. Is it context to where I'll have to think about that one? Thanks for asking that. Yeah, the contexts are encoded in the coordinates. Thank you so much, Fred. That's exactly what I was thinking. Okay, guys, so if you look at what I just sent here, you'll see at the top there, I believe there's a key here. And the key that you're going to want is the SK key. That's the open AI key. And so what you want to do is go ahead and go to the link in the slides. Let me put the link in the chat. We can all go there. And we had actually discussed this one, I believe, the last time. So you guys can go there. And when you go there, you can go ahead and take that key and you can paste it in and it'll run for you, okay? And we're actually going to look at a vector in vector space. So here's your vector. And is everyone there? Are you able to go there? So what you want to do is go ahead and make sure you give me a like, okay? So that's the only thing I'm asking. So, and we're going to look at a few of these today. So this is just the beginning. So take that key and you're going to paste it in. Now I will be deleting these keys after this presentation, of course, but you have them for today. And you just paste that key in, and then you're going to put something in here, and let's just vectorize something. Say hello everyone, and that's everyone, and I'm going to do that, and I'm going to create a vector, and it's going to generate a vector for me, and that's a vector. That's what it looks like. It's an embedding, and you can see there are 1,536 of these. And when you open one up, you can see it has a number. It actually has, you see the first 99 numbers. And in that, you can see there's 18 places. So let's start doing some math. How many possible vectors are there in this space? Well, if you go, what is 18? So there's 10 possibilities. That's 10 to the 18th. But there's 1,536 of these. So there's 10 to the 72,000 plus possibilities. So it's a huge space, all right? And it doesn't matter what you put in there, it's going to be vectorized in this space as a single point. This is a single point in multidimensional space. The reason why this doesn't go well at the beginning of computing, right, is that if you put an A in there, right, it's still 1,500 and something dimensions, right? So that would be a very difficult way to express just A, B, C, Ds, right? So what you're going to do is it works now because we have so much computing power, and and this started off, of course, with video cards becoming so fast and parallel processing. Fred, you had a comment, and X2 for plus and minus. Yeah, thank you so much, Fred, for that comment. I didn't think of that one. So that's a vector. So welcome to the embedding, and there's all types of different embedding models, and they're not all the same. One that we'll be working through with Pinecone has 786 dimensions, so it's a little bit of a different embedding model. But one cool thing here, guys, is that you can look at the code. So if you click on Files, you can go to app py, and you can actually see how this was built. Okay. It's not a lot of code. And that's the great thing about a lot of this stuff. It's all Python packages, and there's a utils one right there as well that's pulling in the API key. All right, cool. All right, so I wanted to show you that so you get a feel for what these vectors are. Okay, that said, any questions? Fred, thanks for that comment. You're right. Let's go next slide. So what's happened is we started off with these large language models, and which is queries, and they require knowledge for internal or domain specific information it doesn't have. So whatever it's trained on is trained on it. It doesn't know any more than that. But so in order to extend them, we came with this idea of using these vector databases. So these LLMs will talk to these vector databases, and where this really works, where it kicks, say, more example, you might have a talk center, or you may have an extensive user guide. And you can put that user guide up, or you can put that talk center up, and you can have a bot that actually is talking to people as if it's a real person, and it's getting its answers from whatever you put in that vector database. So it's like, I think someone mentioned another brain. It's almost like you've expanded your brain. So the first brain, the LLM, is kind of frozen in time. It's whatever you trained it in. But the second brain now has that vector database that you can talk to and pull information out. And you can immediately start building these vector databases without much work. And I'm going to show you a vector database where you can just load documents today. Okay. Any questions so far? All right, just kind of the way it kind of is going to go. You got all these different data sources like code and structured data, unstructured data, and you're gonna vectorize it and throw it up in a database, and it's going to chat back and forth. A hippocampus. So thanks, John, for that comment. John says hippocampus. Yes. All right, with that said, just going on a little bit more with it, a few more slides with the vector database so you guys get a good feel of the overall architecture. You get a document. You're going to chop that document up in something called chunks. Those chunks can overlap. We'll talk about what that means in a few moments. And that all will be going into a vector database that will also, in a sense, create a vector prompt that you'll kind of do a comparison, a nearest neighbor, to find the answer in that vector database space, excuse me. And here we go. And here it is. We're going to talk about the architecture of building a vector database system. So architectures are real important to me. We're going to walk through each step of this, and that has to do with document loading, splitting, storage, retrieval, and output. Now, this actually is not something I came up with. This is from the LangChain chart. So if you open this link at the top, excuse me, LangChain docs, and you open this link at the top, it's pretty much the same discussion I'm about to go through. So I'm going to walk through this discussion, give you all the key points, going to show you how to build that system using prompt, and we're going to move on to a more advanced example. So let's do that now. All right, the first thing you do is you document load. All right, so let's go to the next slide. All right, so let's create a pipeline step by step and query against a blog post. So in this particular case, what they do in this example is they create a pipeline, since starting with document loading, that loads a blog post using a web-based loader, which uses, in a sense, on the back end, Beautiful Soup. So if you're familiar with Python, you're familiar with Beautiful Soup. Now I'm about to show you something that blew me away. Well, that's a web site, but what if I want to load something else? So if you go to this link up here. Let me go and put this link in the chat. If you guys don't have it, you can go to it as well. If you go to this link right here, you're going to see all the document loaders that LangChain has. So let's go to that. LangChain has 158 different document loaders. So you can just about document load anything you want. And it's really easy to stack these document loaders up. I'm going to show you some code today on how that's done. Cool. All right. Any questions on that one? All right. Pull that down. And here's the code for it. Just to go from langchain.document loaders, import web-based loader, and then web-based loader equals the website that you're loading. Now, if I wanted to extend this and, in a sense, make a interface that I put websites into, all I'd have to do in ChatGPT is tell it to do that for me, and it would create that interface for me. I wouldn't even have to write it. All right, let's move on from there. Next, so now what you have in the power of your hands is the ability to load all these different documents very easily into a vector database without much work. So you can add, Excel, open weather, data sets, Wikipedia, tweets, personal data, PDFs, stuff from GitHub. This can all go into a vector database, and it's fairly easy to do. Look at all those document loaders. So it's the power at the tip of your hands right there, being able to do that. That said, the next step is splitting the data. So once you load it, you need to split it because it could be a substantially large document. So you want to split it into chunks. And so the two concepts I want you to get here from this discussion is chunk and chunk overlap. Does anyone have an idea why I might want to have a chunk overlap? I think Ann just answered the question to keep the context of the previous chunk. Absolutely. To feed forward, absolutely, Fred. That's good. Preserve context free. Yeah, you're all right. And what it is it may be that I chunked something at 512, and I chunked the next something at 512, and it had to do with the thing before, but I'll lose that context if I don't, in a sense, have an overlap. So you can choose the overlap. I have a program today that you'll look at where you can actually change chunk size and chunk overlap as you add the data. So splitting, but splitting with chunk size and splitting with chunk overlap. Okay, so that's the next concept. The next concept in the workflow is storage, which will also involve embedding. So to be able to look up a document, to be able to look up our document splits, we first need to store them where we can look them up. The most common way to do this is to embed the context of each document and then store the embedding and documents in a vector store. So that's exactly what we're talking about today. And so go from LangChain, you're going to pull up the open embeddings. Okay, you'll get used to that if you start working with these databases. We're actually specifically from LangChain going to look at Chroma. All right, that's pretty cool. And in that vector-based Chroma, we're going to add those document splits with those embeddings. Okay, so that's how the code looks. So you get used to these patterns because you'll be using them over and over again. Let me see, there's a comment here. Chroma is a local database, but you can persist it. So there's a flag in it that you can actually save it to your local as well. So with that said, we'll move to the next one. And in step 4 is the retrieval. And basically in retrieval, what you're doing is you're embedding your request, as we've mentioned, and that goes to your vector database, and it looks for where other pieces in that vector base are similar to that request, and then LLM will interpret that as your answer. So that's pretty cool. That's just really blowing me away. And the last one says generate, and pretty much you're going to see this, and I want to point just one specific thing here, and then I have something really cool to show you. So basically, you want to distill the retrieval documents to give you an answer through the LLM. So you're going to feed that LLM, and in this case, you got Open Chat, you have Turbo 3.5, the temperature is 0. What temperature is in AI is a temperature of 0 means don't be creative. A temperature of 1 means really be creative. So if you're a fiction writer, you might want to go for a 0.5 or a 0.7. It's all factual and scientific, you might want to keep your temperature to 0. And then what you're going to do in LangChain, because it's called LangChain, you're going to create a chain. And so we have a retrieval chain here with our LLM in it, with our retriever vector store in it, and you're going to see this run chain. So I want to keep that in mind, this pattern of running that chain that has that element that's going to retrieve the vector that's going to talk to you like a human. Now, with that said, I want to take a look at what I consider extremely important website. This is one here below. And I saw this, I went, oh my goodness, you got to be kidding. This is OpenAI chat. Okay, Fred's got a comment. Fred, within a chunk, does position, index of dimension encode the sequence of words? How is the sequence of words or symbols encoded there? Okay, Fred, to answer your question, it's a little bit complex, so I'll mention this. And where this was discovered is in Google Faces. So what happens is in Google Faces, what they did is they began running these neural nets over and over again to his faces until they began to chunk things. Okay. It's that discover, chunks or how things were put together. And then he came up with a million pieces of a face. And that from a quantum mechanics perspective, that's called a basis set. All right. That's what your embedding is. It's a basis set. And then they put all these, and so a face could be made of, like 1,500 dimensions, right? And so you have this point in multidimensional space, and then you take a camera shot of someone's face and you chunk that into a multidimensional piece. And if the cosine vector between the two was the same or very close, then that was a match. All right. And so that's how it works. And the same thing works for text. It's something, and what you have to understand, it all has to do with nearest neighbor. In multidimensional space, if two things are very close together, then they are close to being the same. Okay. Now, how the sequences of words or symbols are encoded, then you're going to want to go to and take a look at Word2Vect and move on from there, because that was a few years ago, and they've done, and it is relatively complex. I mean, each of these different models have their different type of vector encodings, and so you need to dig into those papers, Fred, to understand the specifics of those. Okay. And Fred gave me a thumbs up. Thank you, Fred. I probably talked too much. Okay, with that said, there's this wonderful site, and the links there on the PDF. But if you scroll down this, and typically you go to one of these sites, you scroll down, scroll down to the bottom, and at the bottom they have examples. Oh, this just makes me so happy. And as you scroll down and see these examples, I want to show you a few things. I'm looking at these, and I'm really specifically interested in agents. And I'm just going la-di-da-di-da-di-da, and suddenly my eye gets caught on what? Agents, GTPT, and suddenly I see two-player Dungeons and Dragons. Yes! I can program that. So I can't wait till after this meeting. I'll probably be doing it later today, programming Dungeons and Dragons using AI. But what's happening with these agents is they're setting them up and they can talk to each other. And it kind of started off with auto chat GDP. I don't know if you guys heard about that. And then it went to the dungeon where you had two people in prison and they were talking back and forth. Then they built cities where people were walking around talking to each other. So these generative AI agents are taking on personalities and they're chatting and they're interacting. And why is that important? That's important because I might have someone who's doing a task that my AI agent could do, right? So instead of me having myself work so hard, or that person work so hard, let him do something else that's more important. Let that agent do that job. And so that's where the money is, right? That's where you're using these agents to make things more efficient. And that's what I'm saying. The product of AI is not necessarily accuracy. The product is efficiency. So I got to tell you, I just was really stoked when I saw this site because it just has all the stuff that I'm interested in. So I can't wait to dig deeper into it. So you'll be seeing all this in a month when I start that presentation. All right, so let's move on to the next topic. And that topic is putting it all together. So if you look at that, the first part is my API key. I'm going to bring that in. And my second part, step one, is the load. And my third part is the split. And my second part is the split. My third part is the embed. And my fourth part is to query. And my fifth part is the LML. So before I put this into ChatGPT and ask it to write this program for me, are there any questions? All right, let's move on. So one thing you can do, and I won't go through the whole steps, but I'll show you what I would do. I would just take this code. I'd bring up ChatGPT. All right, let's do that. And I'm going to kind of say the same thing. I'm going to say, write a LangChain and streamlit program that uses Chroma deep, and it doesn't, by the way, ChatGPT doesn't mind if I spell it wrong. It figures it out. Chroma DB. Put the API, open API key on a sidebar. He knows what that is. And use the code and use the following code as an example. And you put the code in there, programming by example, and you run it. It writes it. This is amazing. I'm just blown away, So anyway, we won't spend a whole lot more time with this example, but you can see it's just going for it. It's like automagical. So with that said, let's move on to the next example. But before I do that, are there any questions? Okay, so are you guys still with me? So okay, chunk size. What do you want to know, Matuka, about chunk size?
So how you are dividing the data?
I think a chunk size, it's not quite right, but I think a chunk size is almost like number of words. And it's not quite right, but you can think of it as number of words. And then with those number of words, like you might say it's 500 or 1,000, you have to decide for your system what the right chunk size is by experimenting with it. And I'll give you a program where you can play around with it. But once you figure out what your chunk size is going to be and your overlap is going to be, what will happen is you'll get metadata at the end of each one of those chunks. And that metadata will help you work through the indexing. Fred says, do the resulting programs often need debugging or are they mostly correct? I've written programs, Fred, that are completely correct. They run right out of the box. And then I find ones that have one or two issues. And I got to tell you, it turns out that issues are issues anyway. They may not have been issues that what I'm finding surfacing are issues with the code itself that was already there, not with issues that were created by ChatGPT. So isn't that interesting? And so it's getting better. Let me just say that. And when I first started using ChatGPT, it wouldn't code in Kubernetes. Now it does. And so I saw something on the web there, and they're talking about releasing things slowly. So they're starting to continue to release and make it better and better. But right, Fred, that's a good question. But really, what I'm finding are problems that I have with the code typically are problems that were there before ChatGPT had, and I'm debugging something that was an issue with the code already. Yeah, good question. All right, let's see here. We'll move on. And of course, we are going to be working with ChromaDB. It's a nice site there. Yeah, we'll go there real quick and take a look. Okay, and there's ChromaDB, and you can read all about it, and they have examples that you can go through. And of course, if you're getting into vector databases, Chrome is great because you can play around with it on your local, and you don't have to worry about any expense or the complexities that you might with another database. With that said, we're going to talk about understanding these programs. And so this program here that I'm going to talk about today is a real simple program that we're going to walk through and show you how it's built. And it's a ChromaDB a piece. And what this program is going to do, and we'll run it here in a moment, and I'll go ahead and put the link here, guys. And you can actually run it yourself if you'd like to. And I have a few text documents you can download. One is Genesis, and the other is the State of the Union. And I'm a physicist, so you can imagine I've read the book of Genesis. So if you're a physicist, nuclear physicist, you should know that book. At least Einstein did. Okay, with that said, let me so you can drag either one of those. I have the State of the Union as well. You can download that and drag it into the interface. So we'll do that in a moment. So the way this is constructed, there's a sidebar and there's the middle part, and this is all done through Streamlit. And so in the sidebar, you have your API key. So you guys have the API key. You can go to the link that I put in there. You can put it in here and it should run. You'll drag a text file onto that, okay? And then you can change the chunk size and the overlap and see how that changes your responses. It gives you a chance to play around. And then you can click add data and it will add that data to the Chroma database. All right. And then you can come in here and ask it questions about the data that you added. Okay. So with that said, let me just talk about Streamlit. And when you're looking at this code, you need to keep certain things in mind that and help you understand the code. First of all, one of the top statements of the code is import Streamlit as ST. So once again, if you want to look at the code, you can go to the ChromaDB Meetup, and in that, you can look at the code, it's in the file. Now make sure when you go to that application that you leave it like. Once you go import Streamlit as ST, then you have a with sidebar. And everything you put under that with sidebar in the Python is going to appear over here in the sidebar. So I start with ST text input. That's the input for my API key, and C type password. That gives me that little hidden eyeball so I can keep the password hidden. The next thing I did was have a file uploader so I can drag text on there. You can see the st.file uploader, that's the Streamlit uploader. And the next thing I put is I want to put in some numbers. So here's a number input for chunk size, and here's a number input for chunk overlap. So just st.number underscore input. And then I want a button, I just go st button, add data. And so when you look through the code, you need to keep your eye out for that ST because that tells you that's an interface. And that's the Streamlit interface. So here's one for my text input, ST text input, and here's one for text area output. All right, so that's the Streamlit code, interface code. Let's run it. see how it works, and then we're going to look at the code, the design pattern that we just went through with the 5 steps. Okay, and actually walk through the code and talk about it. So let's do that real quick.
Yeah.
I actually test all these demos before I show them to you guys. So I do due diligence, but the demo gods aren't necessarily always nice to you. So let me bring that text and drag it on. There it is. All right, and now let's watch it be absorbed by the database. So what it's doing is going through that process. The files have been uploaded and chunked and embedded. There it's on the database. And now you can ask questions. What is this about? What is in here? And I didn't spell about right, but let's see if it figured. Yeah, it doesn't care. Based on the context provided, it appears to be a passage from. Oh, it remembered. Hey, oh my goodness, looks like it. What did I put in there? It's got the State of the Union and the Bible. It put them all in there for me. There you go. So let's say how many children? Let's see, this children did Abraham have? Let's see if it remembers that. Oh, okay. Ishmael and Isaac. We'll move on from that. But guys, you get the idea. Any questions about this so far? Because we're going to walk through the code now. I'm going to walk through the code now and show you how this is built. I'm going to walk through that design pattern that you're going to see over and over again when you build these type of applications. Okay. And so let's start with the loader. And so basically you want to load a text document. So LangChain has a text loader. So pretty much what you have is from LangChain document loaders import text loader. And loader equals this text loader and data equals loader.load and return data. That's pretty much all there is to it. But maybe you want to make something more complicated, or maybe you want to load more files. And so I have a more complicated document here, and you can go look at the code as well. And it's upload a doc, and you need to go in and look at the code as well. Okay. And so if you look at that, you can see I've actually just stacked them all together. And so if it's a PDF, it's a docs, if it's a text, if it's a CSV, so it will load all these different documents. And what I do in order to do that is I do a split on the file and I pull off the extension and I do a if on the extension. And so whenever I see a certain extension, for example, the PDF loader, it will bring forth the PDF loader, or you can do the doc loader, or you can do the CSV loader. Okay, do you see how that works with the if statements? So that's one way of just stacking this up to load. If you have a whole bunch of different type of documents that you're loading into a vector database, this is one way to do it using the LangChain loaders. Okay. Any question about that one? And once again, if you go to the file itself, you go to Hugging Face and you pull that document loader up, all right, that has all that in it, and you want to see that code, just go to code and just go to app, all right, and you can actually see all the code that I'm talking about today. You can download it and you can create your own Hugging Face. All right, with that said. So that's the loader piece. So that's step one. Anybody remember what step two was? Step one is loading. Step two is, what do I have to do to my document? Maybe really large. Split and chunk. So split and chunk. Someone said chunk. Someone said split. You're right. So the next thing I want to do is I actually want to split that data. So you're seeing that same design pattern. So I come along here and I split that data up from LangChain splitter, and there's a recursive text splitter that does that for me. And you can see those two things in there, that chunk size and that chunk overlap are in that splitter. So it's important to keep that in mind. Okay. That's all it is to it. And once again, with that, what I just gave you, the code I gave you, you can play around with that chunk size and that chunk overlap and see how that changes your responses. And you don't have to use my documents, just use whatever text document you want to. And it doesn't really have to be really well formatted either. That's what's cool about this stuff. You just throw it in and it figures it out. Oh, so with that said, the next thing we're going to do is we're going to embed and push the data into a Chroma DB. So that's actually fairly easy to do. You just define this function as embedding, and you do the embedding open equal AI embeddings, and you do your vector store, and you got your Chroma dot from documents. There's your chunks that you created earlier. You throw it in with embeddings, and you return vector store. And that's it. And right here, you're embedding and you're shooting it into Chroma DB. That's so super easy and so super cool. The last step is to retrieve using your LLM. So just a few things to point out here. Here, you're defining your LLM using chat OpenAI, using the 3.5 turbo model with a temperature of 1. That's going to be very creative. There you go. And the final thing I wanted to point out, you're going to see this pattern over and over again, is chain.run. So LangChain, it goes by its name. It creates chains. And you'll learn as you work with LangChain to chain different things together. And it actually was written to build agents. And we'll be building agents next time we get together. So once again, just kind of an overview of what we just did. is we created vectors. We queried against a vector query. We found a match, and that match came back to us because we had a query that was close to some data we had out there in multidimensional space. That's a game that's being played here. All right, we got about 25 minutes. We're going to do Pinecone. So are there any questions before we move on to Pinecone? All right, we're going to talk about Pinecone. I like Pinecone. You get one free database with Pinecone. So let's go ahead and take a look at the website. Is this website at the top of your, and put it in if you guys don't have that. We're going to Pinecone real quick. And what I really, really like about Pinecone is two things. I like the fact that you get a free database, and so you don't have to pay for it. That's cool. And so you get to play around with it. The other thing is Pinecone just has some tremendous training. And there's a lot of documents that I put in the PDF where you go there and you learn all about vector databases. So they're not just about giving you a product, they're about training you to learn how to use it and understanding the theory about it. So if you really want to know more about vector databases, Pinecone really has examples and support and documentation, and they talk about how vectors work and how the database works, how embeddings work. So they really do really good due diligence on their training. That's what I'm trying to say. So that's what it's really good about. Now, if you log in to Pinecone, it's free. You don't have to even put your credit card in. You can create a one vector database. Okay. And I called mine chatbot. And if you take a look at that, API keys, you can see the environment's called GCP starter. And this is actually the key. And I gave you that key. So we're going to be using that key today. And I will be erasing that key after this meeting. So with that said, let's take a look and see how a Pinecone database is constructed. We're on Pinecone. I mentioned the interface and the API keys. And I also want to say that a lot of the code I'll be showing in Pinecone today actually comes from a really good site on Udemy. And so I wanted to give you guys a lot more. Now, I am pretty much like of an architect mindset. I like how everything flows together, but I hate the details. But you guys might really need the details on how this was put together. That's why I actually use this particular example. So if you purchase this guy, his Sharath Raja's course, he'll walk through very much of the details about what I'm going to show you today. However, I did modify his code a bit to make it easy to use, but that doesn't matter. It pretty much is still the same. Okay. So with that said, let me say about Udemy. If you buy a Udemy course, wait for the deals because one day it's going to be $100 and the next day it's going to be 10. Okay. So wait for the deals. Don't spend a lot of money. But this is a fairly good course. The name of this course is Mastering LangChain, Build AI Apps, Open AI, Llama 2, and Hugging Face. So it does give you some info on that. And he does build out this Pinecone, but I actually enhanced this interface a little bit. So what he does in his code, he actually has all these values hard coded, right? Many of them. And what I did, I pulled them out into an interface so you can do input. All right, and so let me talk a little bit about this input because once again, you're looking at this ST. Can anyone tell me what ST stands for?
Streamlit.
Streamlit, yeah. So it's your Streamlit. So whenever you see a ST, you know you're talking about interface. And all of these ST sidebar text are all interfaces. So that's interface, 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 interface. So when you go through the code, you're going to see that. When you see ST dot sidebar button, well, that's a sidebar button. So that's easy, just really just very human readable. When you see prompt.st.text, that's intertext, and once here you can have these slider bars, so it's st.slider. Now let me tell you why Streamlit is so extremely important. I used to work for the EPA, worked for the EPA for about 3 years and doing subcontracts for them. And I built Python, right? Because it crunches data. And then we had to really work hard to make that display, get out there in a web page. And Streamlit does it for you so easily. And that's why it's so incredibly important. You can write all this Python back in, put a Streamlit interface on top of it, or tell ChatGPT to put a Streamlit interface on top of it, and immediately you're out. You're out on the world, right? I think Greg Kent had a comment here. You can take the course. Oh, there's a Udemy course right here for free if you can access Gala Udemy. Thank you so much, Kent.
It's the
Go
same
ahead.
course you recommended. It's the same one you pointed to. I'm just pointing it to the free version.
Well, thank you so much, Ken. I appreciate that. I will make sure that I make that part of the next presentation. But that's great because I'm all about saving money. Let me tell you, that's really cool. I'm gonna paste that down here in my this may get away from me.
Gale just requires like a library card or like an education, like a university.
Uh-huh.
Something.
Excellent. Thank you so much, Ken. That is really good news. And someone had mentioned that last time, and I didn't pick up on it that quickly. Did you mention it last time, Ken?
Yes, yes, I did.
Oh, thank you so much. I'll make sure that's actually in the beginning slide so people can see that and move on to that. That's a good comment. This is what the interface looks like, and it's just so easy with Streamlit. With that, I also want to mention something I had not talked about, and that is session state. Streamlit makes it easy to have session state. And so it's just st.session_state, and then you can have whatever you want to put in that session state. In this case, you had the web URL, excuse me, the API key, the Pinecone index, the Pinecone env, the Pinecone API key, the state session API key, and the history. So you can keep state. Now, if you've ever done any JavaScript programming, you will know how important keeping state is and why you need something like a singleton. Wherever you're in the code, you need something global so you can actually pull that variable. And so Streamlit does a great job of that. Here's how that code looks. All right, with that said. All right, let's walk through the step. The first step is loading. So what you're going to do with this is you're going to create a function basically just to load the data. Now, if you're a Python programmer, this may be new to you, this async.co. And what async.co does, it does things asynchronously. So if you're Python, you're probably used to everything being synchronous. This gives you the asynchronous piece to be able to do a sitemap loading. So what the heck am I talking about? Let's run the program. All right, so I'm going to go ahead and put this in the top here. I'm going to show you guys how to run this program. What this program is going to do, it's going to go out and is going to scrape a website sitemap, okay? And it's going to bring that sitemap into Pinecone. And then what you're going to do, you're going to query against that sitemap. So let's go ahead and bring up the program and tell you what I'm talking about. And this sitemap loader actually kind of runs off of the web loader that we talked about earlier. And on the back end of that is Beautiful Soup. So if you've done any Python programming, Beautiful Soup allows you to scrape the web. Let's go to this website right here. I'll pull it from the document. Now, it turns out that many websites have what's called a sitemap. And what a sitemap is a compendium of all the URLs of the website. So what this program is going to do is going to go through and scrape all the information from these URLs. Isn't that cool? Yeah. And so what you want to do that is you want to make sure you put in the website you want to scrape, put in your Hugging Face ID. So let's do that together. And if you're following along and you're going to the program, I will ask you once again, leave that program a like. All right. So let's do this. Here's your Hugging Face. It says HF. That's your Hugging Face. So put your Hugging Face in there. And then I have my Pinecone is index is called Chatbot. You saw that. And my Pinecone environment is called GCP Starter. And then I want to put my Pinecone API key in there. So go ahead and grab that API key, right? And go ahead and click that. Put it in there. And at this point, we're going to load the data. Now, I've already loaded this data, so I'm not going to load it again. But you guys go ahead and click that and see what happens. What do you think? As a matter of fact, you guys are all loading to the same database. So I probably shouldn't have told you to do that. All right. Anybody have any success? What's going on with on your side? Oh, no worries. Let me go ahead and proceed anyway. If Shreya says it's still going to run, and it does run. It takes a while, Shreya. This is a lot of data. So it's bringing in all that data and it's putting it in that vector database. And I can query against it. Now, I don't know what it's going to be like when I got 10 guys loading to it and I'm querying. So this is a new test for me. So I might say, find a job. This is a job website in IT. So let's see and let's go ahead and I'm going to enter that in. Let's do a search on that. And I can tell it how many documents I want it to return. So I do a search on that. And he took that question, embedded it, threw it in a Pinecone, and found the results in multidimensional space, which is really good. So it says, hi, I have a total of 7.5 years of experience. So it's actually giving me the resume for this job, okay, and what I need to have. And then I can go to a link. So basically what you've done, you're scraping all the job advertisements. So as opposed to having to go through all of this, the whole website and picking through the job advertisements, you can put it in a vector database and just search whatever you're looking for. Yeah, thanks for coming, Shira. Thank you. I appreciate it. Yeah, I'm glad you learned a lot, Shira. And I'm actually going to be putting the video up, so watch for that. So if I click on the link, it'll take me to the site where I want to go. All right, and I can find out who's hiring. There you go. So this is very useful for whatever you might want to do. So that's an example of the website and what the website is doing. So then let's walk through those steps we were talking about that builds this code, that design pattern. So we talked about session state, and I use that throughout this program. Once again, we're loading and we're using the sitemap loader, which I mentioned was built on the web-based loader, which is built on Beautiful Soup. The next step, anybody can tell me what I'm doing next? What's the next step?
Split.
I split. There you go. There's
Done.
my splitting code. I use that recursive character splitter. And I'm going a chunk size of 1,000, which is around 1,000 words, a little differently, but it's a way of thinking of it with the overlap of 200. Okay, so I split those documents. The next thing I'm going to do is embed. So I'm going to come along here and I'm going to I'm going to basically do my embeddings. And this is the model I'm going to use for those embeddings. And then I'm going to push the data into Pinecone. So if you look at that, there's a lot of stuff here on this particular piece of code. There's the Pinecone API key, the Pinecone environment key, the Pinecone index name, the embeddings, and the docs. So all that's getting embedded and brought into Pinecone, which uses the API key. And let's go to the next one. And the next one is going to do retrieval. But what I'm really interested in is the last thing I taught you about, guys. What do you see here? Chain.run. I do some multimedia stuff, and sometimes I need to do a text to speech. Let me see if they have a text to speech. Come down here, and here it is, text to speech. So I click on that, and it'll show me all the models that I have available. And so I can use these models. And so I don't know which one I would click on. But if I click on one, typically they're going to have, along with that, is example code on how it's used. Okay, there you go. There's your example code. Now, it doesn't give you an interface, but you can come along here and just copy all this stuff right here, right? Go into ChatGPT and say, build me an interface. And it'll build you an interface so you can interact with this model. And if it has various components in here, you can actually give, different components to give you ability to interact and figure it out and understand how it works. So that's one way how you can work with those models. Great. It's like 385,000 models, something crazy like that. All right, with that said, I mentioned the run chain lang, which is my signature, always be looking for that when you build this type of code. And that is the end of today's presentation. I want to kind of do a little bit about next month's presentation. What has happened in the evolution of all of this that we've started off with. A lot of us started seeing ChatGPT and the simple one-shot stuff and going, wow, it's really giving me some good stuff back. And we were doing simple LML calls. We were doing one-shot, few-shot, train of thought. And then it suddenly came vector databases. And we could extend these LLMs, and we could use these vector stores, these vector databases to extend what we can do with it. Like we have a call center and want a bot that talks to people. Well, suddenly we just take all that call center data and we put it into a vector database and we hook it up to an LLM, and now suddenly we have a bot that's talking to people as if it's a person, and you can't tell the difference. And then now along has come agents, and agents can operate independently as a member of a Scrum team. And so now we're working with agents, and then you can add vector databases to those agents as well. So we'll be looking at that in about a month, and I'll get that presentation announcement out there. So that's really all I had for today. I'm actually 6 minutes early, which is really nice. I typically enter right on time, but I'm actually now 5 minutes early, so it's pretty good for me. But Thuka, thank you so much. She says, nice presentation. Thank you. I appreciate that. Appreciate it so much. And I'm going to be here for a few minutes if you guys want to talk about anything. Agents as a Scrum team. Absolutely, John. That's what I'm building for my presentation on the November 18th to the PMI Southwest folks. Yeah. Absolutely. You'll see that next time. Yeah. Why did you specifically select those vector stores? I think that right now that the two reasons I chose. There's a bunch of them, and I'm glad you asked this question. So let's go back and see how many vector stores there actually are. There's a link up here that I gave you guys, and let me go back to this one right here. And if you go to this link, integrations, LangChain, it's in the chat, and you bring that up, you can see if you click on vector stores, there are like 1 million of them, right? You can look at all these different vector stores. They actually show 57 of them. And the reason I chose ChromaDB is because it's local and it's really easy to work with. And the reason I chose Pinecone is because they're out there and they have such a big educational piece. And and one database is free. So that's why I chose those two. But there's a few others that I could show. But these two, once you learn how to use these two, you can use any of them. They pretty much all work the same. I want to make sure you get that design pattern, those five steps, you know. You want to load, you want to split and chunk, you want to embed and shoot it up into the vector data store, and then you want to retrieve, right? Those steps. Yeah. He says, thanks, Mike. Thank you very much for attending. Guys, feel free to ask any questions because I'm here for you for the next few minutes.